Welcome to the 2024 presentation of the BEST control system. This video will be included in your BEST National Registry in your team's workflow. In 2024, we will be using the VEX Cortex, joystick, and communication keys for the last time. Starting in 2025, we will transition to the Gizmo system, which is Pico-based. The remaining components in the BEST control system will remain in the returnable BEST kits.
My name is Nikki Baird, and I was a mentor and coach of a BEST robotics team for about 6 years, and this is the control systems presentation. This is definitely one of the more technical presentations. However, for those of you who are not technical, be assured this is almost literally plug and played. I am not a technical person and managed my way through these control systems for all 6 of those years, 3 very heavily involved on the engineering side. And if you are technical, don't worry, there is plenty here that you can dig deeper into if you really want to maximize the use of these control systems as part of your team build. Control systems really covers everything that you will get in the return kit. So you will get a joystick, which I can almost guarantee will be the first thing that goes into the hands of your students as they look at the return kit. It also includes the controller, which is probably the most important part of the return kit. It is the part that controls all of the motion that you are able to make your robot capable of. There's also a AAA battery charger. We'll talk about that a little bit more when we get to the joystick part. It comes with 4 servos and as well as servo extensions and extension cables. And then it comes with servo horns. So these are the things that you attach to the servo itself in order to attach the servo to other things or translate the servo motion to other parts of the robot. There's also servo mounting hardware. We'll talk about that in a minute, and a USB cable, which is used to connect the Cortex to the computer or to the joystick, as well as the USB keys. There's one Wi-Fi key that goes into the controller and then one that goes into the joystick. Also in the returnable kit, there are 2 small motors and 2 large motors. These are shown in the configuration that you received them at, which is not the same as the standard configuration that comes out of the kit. These configurations were done to protect the robustness of these motors and keep them safe. Additionally, there are motion control components, so these are kind of pulley systems and tensioners as well as hubs that can be used to help translate some of the motor motion to other types of motion on the robot. There is the battery adapter that is attached to the battery and used to connect to the Cortex, the battery itself, and then the battery charger, which is used specifically for the 7.2 volt battery that goes on the robot itself. There's also some motor controllers. Those are important, as well as the screw terminals for motors and screw terminals for cables. You'll note that those are 2 different colors so that you can kind of distinguish the 2 from the red and black versus the white and black, and we'll talk about those a little bit more in just a second as well. This is an example hookup of both a motor as well as a servo and the battery to the Cortex, so that you can get a sense for the minimum that might be required. Note that there is always a motor extension between the Cortex and the motor itself, and there's always a servo extension between the servo and the Cortex, and this is done in part to protect the servo and the motor from damage. It is also an important part of making them function to some degree for BEST specifically, if you're familiar with the larger VEX systems. So you always want to make sure that you have a motor controller between you and between the cortex and the motor, and you always want to make sure you have a servo extension between the cortex and a servo. So let's get a little bit more into the VEX system itself. So that's these two major parts, the cortex and the joystick remote. The cortex is, I'm pretty sure, the most expensive part in the kit that you are given. So it is important to make sure that it is well secured to the robot, but also make sure that you don't damage any of the pieces that are there for attachment. Sort of treat this with care to make sure that it can be reusable for other teams in the future. The cortex is the brain of the robot. This is where the software lives that controls all of the motion parts that you have on the robot itself. And then the joystick is what you use in order to direct that software to actually move those parts. So you definitely consider these two together. And they're important, very important for making the robot move. Digging into a little more detail on the controller itself, you'll see a series of inputs across the sides. The most important ones are the 10 motor and servo ports that are on the right-hand side. We'll go into detail on all of these in just a minute anyway, but it is important to note that, and I'll say this probably many times in this presentation, that while you have 10 ports that you can use for the motors and servos, there's definitely some recommended usage, and you are not to use and very strongly discouraged from using ports 1 and 10. Focus on using ports 2 through 9. You'll see the Wi-Fi key here is black, but the black ones are no longer used. They've upgraded the Wi-Fi so that there's less interference between the multiple Wi-Fi connections that are on a game field. And then there's some system indicators down the side. We'll go through those in just a second as well. This is a better look at the joystick, both the top and the front. The Wi-Fi key actually slides in underneath, so it's not well pictured here, but where it says 2-axis accelerometer, X tilt and Y tilt, it really kind of goes in along that bottom curve of the joystick in order to connect the joystick to the cortex. There's 2 XY analog joysticks. There's 8 buttons on top. There are 4 buttons on the front, 2 on the right and 2 on the left. And that's also where the power switch is, as well as you will find the programming interface for if you connect it directly in an analog way to the cortex. The joystick takes 6 AAA rechargeable batteries. It does eat batteries if you leave the power switch on. It's definitely something that's important among the team to make sure that they are aware of power and the charging of batteries, and that they have a good supply of rechargeable batteries, because that is definitely something that you don't want to run into where you really need to use the controller and the joystick and the batteries are dead. Here's some additional detail about the cortex and controller, the wireless communication. The 2-wire proportional motor control outputs are the 1 and 10 on that cortex that I talked about that we don't use. The servo motor outputs are the 8 that are in between, so slots 2 through 9 in the motor portion of the controller. And then there you have some options for how you actually load the program onto the cortex, and we'll go over that in just a second. And then as well, there is a built-in resettable fuse for overcurrent. I've never encountered that, so it doesn't mean that you can't, but I will say that my team's always stretched the power and voltage options that we had to the limit. So it is certainly possible. It's powered by the single 7.2 volt RC Hobby battery. The battery also must be well secured on the robot. It's probably one of the first things that you need the team to think about. Don't leave that as an afterthought. They should be designing where the battery goes as part of the robot design, because it's certainly something that could disqualify you if you do not secure your battery well. Plus then your robot won't run. This is the more detail on the ports available on the Cortex. Again, the USB key plugs into the Cortex on the top. If you were holding this in your hands, it would be with the USB key pointed down, basically into the slot. And then there's some connectors that are on the left-hand side around the analog in and the digital in out, and the speaker port is labeled SP. We'll go over what the lights mean right underneath those ports. There's the standard serial interfaces, and then also the most important ones are the ones where the motors and the servos go, and those are, again, 2 through 9 on the motor connectors. Don't use 1 or 10. And as well, there'll be more advice here on how to leverage these particular slots, but you always want to have the servo connector, the extension or the motor extension that has the little servo controller or the motor controller on it. That's what you're plugging in here, and then you're plugging that into the servo or the motor. You always want to make sure that you have that connector between the Cortex and the motor or the servo. So if you took that top-down view and you took the top of where the key is sticking out and you sort of pointed that down at the ground as you're looking at the Cortex itself, you would see these ports here. There's the main battery port and the on-off switch, which always make sure that it is on when you want it to run. But that's where the battery plugs in. We don't use the 75 megahertz interface ports, and only the configuration switch is really only used for special procedures. And then there's a backup battery port for Wi-Fi communications, but again, that is rarely used. So when you are connecting motors and servos and sensors to the Cortex, then these are the slots that you want to use, and these are the configurations that you want to look for. So always the ground, always some kind of power, and always signal control, and you can see that they're oriented towards the middle. So the signal control is always closest to the center of the Cortex itself. So on the motors, it's oriented one way, and on the other side, it's oriented the other way. And again, you can see the difference in 1 and 10, where it really only has those 2 ports, and that's why those are not used, and you focus on 2 through 9. So some of this advice I've already covered before, but just to hammer it home, don't use motor ports 1 and 10. You do connect them via the 3-wire external motor controller, and again, you always want that motor controller between the motor and the Cortex. And then there are those 2-wire screw terminal cables that you can use. And then the motor ports that you use 2 through 9, you do want to spread those evenly between ports 2 through 5 and 6 through 9. So don't load everything up into 2 through 5. If you're only using those 4, then you would want to use like 2 and 3 and 8 and 9 or something like that to make sure that you kind of evenly divide the power consumption between those 2 sets. Some additional notes to keep in mind. So the servo and motor ports, as I said, are divided into 2 banks. You really want to focus on 2 through 5 and 6 through 9. This is where amperage comes into play in terms of the draw of the motors and servos on the batteries. That was always beyond me, but for anybody who is electrically engineering minded, you can always kind of set them up for understanding those aspects of how the motors are consuming battery power. I will say that there was one year that my team came up with a design that pretty much sucked battery about as fast as you possibly could, and they probably should have done the work to understand just how much they were drawing in each of the 3-minute rounds. But it takes a lot of effort to get to that level where you could draw that much power that you would drain the battery before the 3-minute round is over. But again, you really only want 2 motors plugged into ports 2 through 5 and 2 motors plugged into port 6 through 9. Do not use port 1 or 10. Also, you'll see the motors in just a minute in a little bit closer detail, but there is a sheet metal shield that is around the large motors, and you should not remove that shield. In fact, you shouldn't really do anything to physically alter any of these parts except for the servo horns. But we'll talk about that in just a sec. So here is an image of both a small motor and a large motor in the Rocky Mountain and Front Range Best configuration, where the cables are already attached, soldered, and sealed against the terminals on the motors themselves, and then the wires are wrapped around and zip tied to the motors themselves. This is to prevent any tugging or pulling or breakage of the terminals that are on the motors. So this is to protect the motors. Don't cut the wires. Don't remove the wire ties. If you really are in a situation where you feel like you need to do that, you probably should contact the hub and tell them what you're planning on doing and why, and just make sure that it's okay. Just be extremely careful. The terminals do break. They're kind of brittle. So that's why this configuration is here, is to protect them for you. And also, I would say it's a troubleshooting area where if you are having problems with a motor that is operating, you do want to include as part of your troubleshooting making sure that these wires are still solidly connected to the terminals, or that nothing has happened to the terminals themselves. Motors must be mounted with the VEX motor mounting kit that is provided. The mounting kit is considered to be consumable, so you can alter the plates that are the motor plates for mounting. And you can see both the small plate and the large plate here. So the large plate has the large hole, and the small motor plate has the 2 small holes in the center. You can also see probably the most standard configuration for how you set up a motor plate in order to attach the motor in a kind of horizontal configuration so that you could use it, for example, for attaching a hub and a wheel. There is a hex wrench for the mounting screws. The mounting screws are very specific to these motors and to the motor mounting kit. So that is something that I encourage you to keep track of and don't lose, and be careful not to strip, because then it becomes very difficult to remove the motors. So those motor mounting screws are actually very precious, and I recommend that you keep track of them. And again, you can alter the plates, so you can cut them down, you can bend them in all kinds of wacky configurations, whatever the plate itself will support, just as long as the motor is securely mounted safely, and that motor mount is also securely mounted and safely attached to the robot. This is the rest of the wiring that is used to attach a motor to the Cortex. So you can see the standard 3-wire connector, which is part of the external motor controller. And then it connects with this 2-wire pin to the screw terminal, and then the screw terminal is what you take the motor leads, the 2 wires off the motor, and you attach them into the screw terminals. The weak points here are definitely those 2 blue components that are the 2 pins that go into connecting the screw terminal, the 2-wire motor cable, into the external motor controller. So you are allowed to use painter's tape to hold these together so that they don't pop apart. Definitely with all of the handling and bouncing and motion that happens on a robot, these are things that can come loose. Just make sure that it is painter's tape or the approved heat shrink tubing or the 4-inch wire tie. Don't use anything other than that, as you can potentially damage the connectors or the pins. And also, this isn't a weak area where if you are troubleshooting, this is almost one of the first places that you should look to make sure that this connection is sound. When you are connecting those pins, you do want to make sure that you're connecting red to red and black to black. That is important. And that happens as well when you're connecting the red and the black from the motor itself to the screw terminal. So this is what it looks like when it's all attached, and you can see the detail where the red wire is lined up with the red wire on the motor controller. And then the 3-pin is what actually goes into the Cortex itself. And then the servos are very similar. Servos have a maximum 120-degree rotation, so that makes their usage limited and different than how you can use a motor, which is the 360-degree continuous round and round. But it connects very similarly, and it has a similar kind of setup in terms of the 3-wire servo power adapter that you are connecting into the Cortex. And again, just like the motors, these only go through into ports 2 through 9 on the motor section of the Cortex. And you want to balance these across the 2 through 5 and 6 through 9. They do come with a set of servo horns, and those servo horns can be modified. So if you need to cut one down or something, then you can. I have seen teams be pretty brutal in how they use these to actually attach to whatever it is they're attaching these servo horns to. But I would caution you to make sure that you are very careful about where the actual motion happens within the servo itself, as well as where the servo attaches actually to the robot. And I'll talk about that in just a second. And again, back to the basic setup for the servo itself, you can see that there is that servo controller. You don't need the screw terminal because you don't have exposed wires there. You just have the pins that have to connect to each other. But again, the white on the inside of the Cortex, when you put the pins into the Cortex itself, and then make sure that you connect the pins white to white and black to black on the 2 sides with the red in the middle for the servos as well. Finally, for the servos, you are given as well some servo mounting optional hardware that you can use. I strongly encourage you to use it. I would also say that the servo mounting screws, just like the motor mount screws, are kind of precious commodities. They're very small and easy to lose, and they're also easy to strip, so be careful how you leverage those screws. But the mounting hardware is really there to help protect the servo and to make sure that you don't damage the mounting holes themselves. So there is enough of the mounting hardware included that you can use them for all 4 of the servos if you want. And I do encourage you to use them. This is a diagram that shows you how to use the optional hardware and use that in order to mount the servo to anything that you need to mount it to. So if you need to refer to this in order to understand how to use the parts that are included. The last set of connections that you can make to the Cortex involve using the digital inputs as well as the analog inputs, the ones that are on the left-hand side of the Cortex. If you refer back to that diagram that shows all of those connectors, these use the 2-wire digital input connectors and screw terminal cables. So you want to use these. You use the digital inputs for limit switches and micro switches, and then we'll talk about the analog in just a minute. But all of those switches and digital inputs come to the Cortex via the sensor screw terminal cable. The digital inputs go in that lower half of the left-hand side that you can see is labeled digital and has the 1 through 12, not including the SP, which was the speaker output at the bottom. So you can see how the sensor cable connector, again, white towards the middle, fits into the pins for the digital input. You use the analog input connections for potentiometers. So this also uses the 2-wire sensor screw terminal cables, which just have the white and black and the 2 pins. And again, you connect the potentiometer into the Cortex via this sensor screw terminal cable. However, these go into the analog inputs sideways, and I'll show you what I mean in just a minute. This is an example of the potentiometer all wired up. So you can see that there are the 3 signal terminals, and then you have a screw terminal for each one of those that then connects into these slots in the analog input connections. And as far as exactly how to use the potentiometer itself, I strongly encourage you to look into the material that's provided and the help forums to be able to really take advantage of this particular item. All right, that's all of the parts. Now let's talk about how you get the software onto the VEX and how you make sure that the joystick and the Cortex are actually talking to each other. You should receive them out of the box already paired. However, if the joystick does not connect to the Cortex, then you may need to resync them. You can do that just by using a USB cable that's included, and you put that where the USB keys go in both the Cortex and the controller, and that should reconnect and resync or pair the controller and the Cortex. The Cortex comes with an out-of-the-box configuration, which is the software that's already loaded onto the Cortex. It does allow the team to hook up the Cortex and have it work without having to program it. And the next slide will show you the configuration that's there. This is called the best default program. It is definitely not the only configuration, and teams really are expected to create their own programs. We'll talk about that in just a second. There should be a whole separate section on software as well. But that having that basic configuration is helpful, that you can kind of get the kids familiar with the returnable kit and the pieces and how they configure together, and let them kind of wire it up and get it operational right out of the box if you want to take advantage of that. This gives you more detail about what's expected from the best default program. So the program that's in there is really using the right motor, left motor. Those are the large motors, and then there's an additional motor in the middle as well as a servo. So you, if you do want to wire it up in order to test it out and kind of just see how all of this wiring works, then those are the ports that you would want to use for the corresponding parts that you are leveraging, that the software would then operate. As far as the software goes and how to program the software, you have 3 different options. You have MathWorks Simulink, you have EasyC version 6, and you have RobotC. EasyC is the kind of drag and drop visual programming model. This is the kind of most basic and easy. RobotC has a text editor. It also has a runtime debugging. And in my experience, the teams have used this the most that I've seen, especially if you have any software kids on your team. They tend to dive into this pretty deeply. Simulink is a graphical programming and modeling environment, and it will actually show you what you are programming and what the robot will do before you download it into the Cortex. This is definitely the most sophisticated. There are opportunities sometimes for additional awards that you can win if you use the Simulink method of programming, or if you use that alongside of RobotC. So if that's something where you have some expertise or some interest in developing that expertise, I definitely encourage you to look into the Simulink options as well. So as far as getting the software onto the Cortex, you have a couple options for doing that, and I'll show you all of those configurations. The first one is the most straightforward. You have USB, and it's the same USB that you would use to resync the joystick to the controller to the Cortex. So you can direct download. You don't need to have the battery attached. In order to do that, the USB will power that download. The next option is a little bit more sophisticated. It is a tethered option where you actually are connecting to the joystick, and then through the joystick you're connecting to the Cortex. This does allow for some more advanced debugging, which might be one option why you would want to use this particular setup. And then you can also do the wireless download, and this is where you are tethering the joystick to the computer in order to download, but you're using the wireless keys, the Wi-Fi keys, in order to actually move the software through to the Cortex itself. In this situation, the Cortex does need to be powered separately, so you would need the battery to be set up with the Cortex in order for this to work. Getting that software ready to go and ready to actually move your robot around is very exciting, so make sure that the excitement does not end in disaster. So first of all, when you are downloading the software and then getting ready to test that the software is working in the Cortex, just make sure that your robot is in a safe place. Don't have it in a place where it could roll off the table, especially if it moves in an unexpected direction, because you need to reverse some motion in the programming, and then make sure that all team members are clear of the moving parts. Then you can connect the Wi-Fi keys to tether the cable, or the tether cable, between the joystick and the Cortex. Make sure that when you first hook everything up, everything is in the off position. And then you attach the battery before you turn it on. You turn on the joystick, and then you turn on the Cortex. And then it should take no more than about 10 seconds for the link to be established between the joystick and the Cortex. And then you should be able to run the operations and make sure that your software is working. The joystick itself has some LED status lights. So the bottom one says game. That one's actually not used by Best. So those top 3 lights are the ones that you will literally live and die by, because they tell you whether your batteries are powered up and whether your joystick is connected to the Cortex. So a green light for both the joystick and the robot battery status means everything is good. A yellow light means you are running low on power, and a red light means that your battery is dead and it needs to be recharged. And again, for the comlink status, yellow means that it's searching, and then the green means that the communication has been established. And those lights are the same on both the Cortex and the joystick, and those statuses are the same as well. So that is the one that lets you know that everything is functioning as expected. Some additional tips. It is recommended that you tin the motor wires with solder before you attach them to the screw terminals. This is so that when you screw down the screws in the terminals to actually attach the wires, that you don't get frayed wires in there, or strands that are loose that can cause a short. And then do not solder wires to the Cortex. Those pins should be just push to connect, pull to disconnect, and that's it. So the Cortex is one of the most expensive parts in the returnable kit, so please handle that with care and do not do anything permanent to the Cortex in any way. The sensor cables, the servo power adapter cables, and the external motor controllers are all keyed in the correct orientation. So just make sure that you're paying attention to the white wire in the center, towards the center of the Cortex, and then take care with those pins. They're pretty fragile, so insert and remove them carefully so that you keep those connectors in good working order. And then make sure you tighten the screws on the connector cables on the screw terminals so that the wires are not loose and do not pull out. Definitely, if something is not working as intended, one thing you need to check is all of your cabling and your wiring and make sure that it's all connected well. You mount the Cortex to the robot using the number 8 screws through the holes provided. Again, be very careful not to over tighten and crack the housing and the holes where the screws go in. And then as well, it's not good to try to insert the USB keys while everything is powered up. So make sure that you insert the USB keys when everything is powered down. And then you do have the option of operating tethered by removing the USB Wi-Fi key and connecting the A to A cable between the joystick and the Cortex. It's just that then you will be literally tethered to the robot. So it's good for testing things really quickly if you need to, but it's not how gameplay will be, so keep that in mind. And finally, the last piece of advice is around joystick calibration. So if you are hands-off on the joystick, but while it's powered up and while the robot is powered up and you hear the motors hum or creep, then what that means is that your joystick probably needs to be recalibrated. The calibration procedure is here for easy reference, but it's also in the EZC help file. You definitely don't want to continue with this kind of operation. It's a bit hard on the motors, but also it drains your batteries. And as you may have gathered from some of my comments, battery charge is essential to monitor and maintain. And then finally, if you need more help, we have links to lots of resources. Google also is your friend, but the best forum is a great place. There's lots of Q&A. There's lots of places where you can ask questions. If you have a question about whether it's legal to do something with the returnable kit, then for sure you can ask here and get some help as well. And then VEX itself also has a forum. This is where you can get technical questions answered about the VEX equipment itself, as well as more advice and forums for EZC and RobotC. If you need more software help, that's definitely a great resource. Again, don't hesitate to use Google. Lots of other teams will post past software designs if you need some inspiration or some starting points for things that you can do with your team. So there are lots of resources that are out there that you can leverage. And with that, that covers all of our control systems in the returnable kits. Thanks.
This video is a part of the breakout sessions for the kickoff. This file and virtually any other file you will need will be accessible at the Best National Registry. So make sure that you have the proper account so that you can access that.